Fire the laser down the track, all the way down. Fourteen thousandths, and another knot, and that should. And I welded some supports here where I could drive some rods down. So basically, it's got to hold tension on this piano wire or a guitar wire. It's a music wire. So I've got this lined up with that blade down there, and I just barely touch it here to adjust it. And I got several 20 or 30 pounds of tension on this wire right here. So now this is welded down right now. Can you see the wire? Mm-hmm. So I'll show you what it looks like down here. Like I say, I'm measuring off this blade. More specifically, I'm measuring off a tooth off this blade. So I've got that PTO disconnected from the tractor, and I put it in a cradle. That way I could spin it like this and it won't get hung up over there, the PTO. So what I do is I measure this tooth right here. I just picked a tooth. I measure from this tooth, holding this level. That's what that is. And then I rotate it around. That way because these have an inset, right? One's going one way, one's going the other. That makes the curve. So I rotate it around. And then I bring it in here, and again, just kiss that wire pretty much level, 3 3/8. It's really 3 3/8 proud on both sides. So now all I've got to do is look straight down on the wire, the piano wire. See right here, I'm looking straight down, and I got it more or less in the groove between these two 1-inch channel irons. So now I'm going to come down and tack it real lightly. Tap, 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 and then kind of move down and follow this wire. I'm going to do it lightly because I don't want any kind of temperature to warp something. So I'm just going to come down through here, line this up, tapping it over, tap, tap, all the way down until we get to the end, both ways. So this bunk is 60 feet long. So the same situation down there, except for the only difference is I've got a turnbuckle down there to give it a little more tension in this wire. So yesterday I leveled this. This is 3-inch angle iron. Leveled this up on the bunk all the way down, firing a laser down it. So it's nice and level this way and this way. So really all I got to do is get this track tacked down with that wire, and I believe we'll be good. And you remember I still have adjustment in the blade. If I get it off a little bit, I can adjust the blade back and forth. So what I'll do is I'll come over here when I drop this carriage down, and I'll measure from the headstock to the blade. Same thing. Headstock to a teeth. Headstock to a teeth. Headstock, headstock. And then I'll make sure the carriage is running true down through there to the blade. I already know that this, because these are two carriages put together, this headstock's 1/8, I believe, back. It might be a 16th, but it's back a little bit. So I'll have to maybe weld a little piece of metal right here or something just to get it straight. So I'm probably 2 days away from getting this going again. And when we started this video, all we were going to do is, remember, mill up this water oak right here into 1-inch boards. And of course it turned into a construction project, as usual on the Triple T. Well, we finally got there. 3-inch angle iron runs from one end to the other on this 60-foot bunk. So we're going to drop this carriage down, set it down on the tracks, and push it down through there, see how it works. And then I'm going to hook up the chain drive, start up the 64 case, and just see how it moves up and down the track. And then finally we'll load up the water oak over here, the one that we couldn't mill, as you saw earlier in the video, and we'll see what happens. See how good the carriage moves. Okay, so I pushed it all the way down here with one hand. That's an improvement. And the rollers didn't run off the track. So all looks good. So the next thing I got to do is hook up the chain drive. Alright, we got a few more problems. When I put the square here on the blade, no bueno, touching here but not touching up here. So that's not good. So I'm going to have to now align the blade this way with the carriage. And this distance right here is consistent all the way down to the back of the carriage, so should fix that problem. And the next thing I noticed was the square on these knees. You probably can't see that, but this one is leaning toward the blade. The next one down there is leaning away from the blade, so I'm going to have to square up all the knees too. I need to reposition the carriage right here where I can get a reading off this blade. Then we'll lift the mandrel up and down, make this square with the bunk. Well, make it square with the carriage, not the bunk. Alright, I've got the carriage in place. We got the knee sitting right above the mandrel. And we've got the square. This is more or less straight here, so I'm going to use this as a reference. So there you go. Yeah, it's moving. It's never going to be easy though. It felt like it bottomed out right there. That bearing is right up against the angle iron on the bunk, so I can't go up anymore. Well, the other thing I could do is drop down the other side. That might be easier. So what I'm going to have to do is get this bearing away from the bunk. And see if I can make enough room to lower it. That's how that bearing works. And we'll check the alignment now. So it dropped down as soon as I took that bearing loose. Damn, that's right on it. And what I've got to do is take off just a little bit right here and then water these holes out a little bit. All right, we got it snugged up. Let's see what we got here. It's pretty good. Still could come down just a little bit. She was level before I started this process. We're out of level that much. Like I said, I don't see a problem other than this belt right there. Let's be out of alignment a little bit. You know, I mentioned earlier that it was never easy with this old sawmill. The more modern sawmills or commercial ones, the frick and the length, all can be adjusted somewhat. This one is always a challenge. But when I said it was never easy, as I sit down in this saw pit, think about the guys that had to cut lumber by hand down in a pit like this all day. So this is way easier than that. So I shouldn't complain. I'm standing on their shoulders right now. So let's see what 1 inch looks like. Yeah. So I'm getting closer. Yeah, this is water oak. It's looking pretty good. You want to do the reveal with some water? We're going to stop this video right here because the mill is cutting well, but to tell you the truth, this little 6-inch cant, it's not a good test for the mill. Everything worked out okay. You could tell here that we didn't let out any smoke, but I've got a big, ugly, mean water hickory, 22 to 24 inches in diameter. It's been sitting on the log rack for a long time, so it's cured. It's going to be hard. That's a better test. I'll get the water hickory cut and show a video on that, and that'll be a real test because it'll be climbing all the way up on the top of the blade. It'll be so heavy that the dollies in the carriage will be creaking. So it'll be a better test. So we'll do that. Hope y'all enjoyed the video. Thanks for staying with me to the end, and I hope y'all have a blessed week.